Barry wrote 6 different numbers, 1 on each side of 3 cards, and laid the cards on the table as shown. The sum of the 2 numbers on each of the 3 cards are equal. The 3 numbers on the hidden sides are prime numbers. What is the average of the hidden prime numbers? So from the problem we have 3 cards as shown, and we can label them as A, B, and C. And each of these cards has a second side. And on the second side we have the hidden numbers are prime numbers. So they're prime numbers. So if we denote these 3 cards as A, B, and C, then we get A equals 44, B equals 59, and C equals 38. Now for the other side of these 3 cards, we can label them as the numbers are X, Y, and Z for the other sides. And we know that all of these are prime, and when we take the sum of the 2 numbers on each of the 3 cards, they are equal. So by that we can write the equation A plus X is equal to B plus Y, which is equal to C plus Z, since the 2 sides are equal and they all equal to the sum of all of the 3 cards. Now from this equation we can rewrite it as, in terms of X, we can do X equals B plus Y minus A, or X equals C plus Z minus A. And now by equating the 2 expressions for X, we get, so write this one and is equal to this one, we get B plus Y minus A equals C plus Z minus A. Now we have the A's will cancel out, and we get B plus Y equals C plus Z, and if we write it in terms of Y, we get Y equals C plus Z minus B. Now to find Y, we know that C was 38 from our numbers over here, and Z, we don't know what that is, and minus 59. So if we replace these numbers with these, then we get Y equals 38 plus Z minus 59, which we know is Y equals Z minus 21 when we rewrite it. So from this equation, Y equals Z minus 21, we need to figure out what Y is. So it says that we need to find the prime numbers since the 3 numbers are all prime. So if we write Y as a prime number, then we can get 2 equals, and Z is also prime numbers, is 23 minus 21. If we do that, then we get 2 equals 2. That equates to the same answer, so that works. So we found out that Y equals 2 and Z equals 23. To our equations, we had the equations A plus X equals B plus Y, and A plus X equals C plus Z. Now from these equations we can solve for X. So if we use this equation right here, then we have A plus X equals C plus Z. We know that A is 44 plus X, which we were solving for, equals C, which is 38, plus Z, which is 23, and then X equals 17 if we solve this. Now if X equals 17, then we know that that was the second side of the first card, so we'll write that here. And for Y, we solve for Y over here. We know that Y is 2, that's the second side for the second card. And Z we solve for 23, and Z is the second side for the third card. So if we average all these numbers, we get 17 plus 2 plus 23 all over 3, which equates to 14. So our answer is B.